All right, so we got a deck of 4 cards. We got the 2 of spades, the ace of hearts, the ace of diamonds, and the 2 of clubs. These 4 cards have the same colors and numbers and a mirror image of each other, so we would say that they are symmetrical. Now, if there is a way to have multiple levels of symmetry where 2 halves of the deck are symmetrical and the 2 halves of those 2 halves are symmetrical, you could use recursion to compute the number of levels of symmetry that occur before the pattern terminates. So I'm going to quickly start by writing the deck class. Now I'm going to quickly tell it how to create the deck. All done with the deck class. Now time to write the driver. Now I'm going to set up the deck that we're going to be working with. Now I'm telling it how to set up the deck. Now it's time to start the symmetry depth method. Now I'm going to handle the base case. Now I'm going to tell it how to divide the deck and compare the 2 halves. This is just some more of the doing the comparison between the 2 halves of the deck. This part is setting up the comparison deck to test for equality. Now I'm going to handle the recursive case. And now it's time to write the main method. Gonna set up the input. And now time to set up the whole processing of the input and output. How to create the deck from the input. And now for the final system out, where we call the recursive equation, the recursive method, my bad. So now I'm going to just run this program that I just wrote. So I'm going to say the 2 of spades, the ace of hearts, the ace of diamonds, and the 2 of clubs. So now I can see what it did here. It compared them and determined that the computed symmetry depth was 1. And that is what it should be. And that's all I got.